Good morning, students. It's Monday, November 1st. This is an A day. And today our learning target is to understand and use exponents and exponential expressions. So I hope you like our new November look for our slides. I'm just trying to keep it fun. So hopefully you've spent a minute just centering yourself, getting calm. Then we'll have our lesson. Make sure that you update your binder by putting your lesson page after the pages that are already in there. So that will keep them in consecutive order. And we do have a fun exit ticket today. So I hope that you are working from your own computer because we have a digital exit ticket that is kind of fun. And also, if you don't have your computer, perhaps your teacher can work with you on the board with that. So let's remember we want to be centered, focused, ready to work. We have our computer and our completed lesson page at the end of the period. Make sure your work is hole punched and that you've put it in your binder. And go ahead and complete that exit activity, which I think you'll find is fun at the end of the class. So make sure you have your lesson page, your pencil, get to Schoology, and begin working on the lesson. So let's get started. Today, we're going to start talking about exponents. So I'm going to go to my blank page for a minute and talk and write down exponents. And you can just watch and listen for a minute. So sometimes when we have a number, such as 3, we might want to multiply the 3. So how can I show repeated multiplication? So repeated multiplication would be 3 times 3 times 3. That's when we take that same 3 and we repeat it in order to perform the operation of multiplication. So what we do is we can take that 3 and we can give it an exponent of 3. So when we do that, we have two parts of, let's use our red, of this expression. We have the base, and then we have this small number at the top, which we call the exponent. And the exponent tells us how many times the base is repeated. So if I have 3 to the third power, and that's how we say it, we say 3 to the third power. Let's write that down. So we call that 3 to the third power. Okay? How can I expand that? And the way I can expand that is I can write 3 times 3 times 3. Now, let's ask another question. What is the value of 3 to the third power? Well, let's look at that. I'll write it again, my 3 times 3 times 3. So what I have is 3 times 3, which is 9. And then I have the 9 times one more 3, which equals 27. So I know some of you may look at that and you may think, wow, that's 3, 3, and 3, and that makes 9. Nope, we're multiplying, okay? Let's write that in big letters. We are multiplying. Okay, so we don't want to forget that. So it's 3 times 3, which is 9, and then 9 times 3 is 27. Let's take a look. What if I were to write 3 to the second power? Now, I often have students who look at this and they say, oh, that's 6. 3 times 2 is 6. No, that's not 3 times 2. The base of 3 is repeated 2 times. So that would be 3 times 3. Well, what is 3 times 3? 3 times 3 is 9. So that's the work we're going to be doing today as we explore exponents. So let's get started. And remember, you are worthy. And this is hard work, but you are worth the effort. You can do this. So let's get some Thanksgiving colors going, some November colors. The leaves are crispy and colorful today. I hope you took a minute to enjoy how beautiful fall is. It really is gorgeous. Just breathe in the crisp, fresh air. So exponents, in the case of repeated multiplication with the same number, okay, we're always repeating the same number, we can rewrite the expression using exponents. For example, 4 times 4 times 4 can be written as 4 to the third power. The parts of the exponential are the base, and in the case of this expression, x to the n power, x is the base. And then we also have the exponent. And in the case of the n with x to the n power, the n is the exponent. So the way we read this is we would read this expression here as x to the nth power. So let's take a look at some examples and let's fill in our little chart here. Let's see what they're asking us to do. We are asked to write each expression using exponents, then evaluate if possible. Okay, so that tells me perhaps some of them are not, we cannot evaluate them. So remember, evaluate means to find the value of. Right? We've used this before, but it always is good to repeat and remember, to find the value of something, to find its numerical worth. So if I have 11 times 11 as an exponential expression, I will write that 11 to the second power. Now, what is 11 times 11? So you might need to use the calculators on your computers for this, or you can do it longhand, but 11 times 11 equals 121. Well, how about 2 times 2 times 2 times 2 times 2 times 2 times 2? Well, how many 2's are there? There are 7 2's there. So I'm going to express that or write that as 2 to the 7th power. Now 2 times 2 is, let's actually spend a minute and go through this. 2 times 2 is 4. And 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, and 64 times 2 is 128. Some of you may have been able to do that without a calculator, but if you needed to get a little help, that's fine. We're talking about exponents today, so our numbers get large very quickly. Let's move on to the next page. So we have expanded notation in the first column. We have the exponential expression, which we will write in the second column, and we will evaluate and find the value in the third column. So we have Negative 5 times negative 5 times negative 5 times negative 5. Okay, so first thing I want to talk about is these parentheses. Those are extremely important. When we have the negative sign included in the parentheses, we must keep it there. So this would be parentheses negative 5 to the fourth power. But let's go to our scratch paper again and think about that negative 5. There we go. Let's scroll down. So if I have a negative number like negative 2 and I multiply it times negative 2, we know from our integer multiplication rules that negative 2 times negative 2 equals a positive 4. Let's do that one more time. Negative 2 times negative 2, again times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Because here, these made a positive 4. Then we multiply that times negative 2, and that gives us a negative 8. But what if we do it again? Let's rewrite this. Negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4. And positive 4 times negative 2, let's write that so we can easily see what's going on. Positive 4 times negative 2 equals negative 8. Now, so we've done this. Now we have that negative 8, and we need to multiply that by negative 2. And that will be positive 16. So I don't know if you can see what's happening here, but when we multiply an even number of repetitions, so an even number of bases, and that would be, in this case, the negative 2, produces a positive number. Okay, and that would be like negative 2 times negative 2, or like negative 2 times negative 2 times negative 2 times negative 2. But where we have an odd number of bases, well, that will produce a negative number. And I hope you can squeeze these notes in somewhere. So that would be our example, negative 2 times negative 2 times negative 2 produced a negative 8. So when we have negative 5 times negative 5 times negative 5 times negative 5, there are 4 bases here, 1, 2, 3, 4. And that means that our answer will be positive. So we have 5 times 5, 25. 25 times 5 is 125. 125 times 5 is 625, and that will be positive. Now, when we have 1/4 times 1/4 times 1/4, we can write that as 1/4 to the third power. And if we just look at the numerators, 1 times 1 times 1 is 1. But our denominators, and let's change the color so we can see that more clearly. 4 times 4 is 16. 16 times 4 is 64. Let me make that 6 a little clearer so you can see it. There we go. Now, we're changing it up a little. Number 5. We have 7 times 7. That's 7, a base of 7 to the second power, times 4 times 4 times 4 times 4 to the third. So that would be 7 times 7, which is 49, times 4 times 4 times 4, which is 64, and 49 times 64, so that would be 49 times 64, and that would equal 3,136. Now let's move on to number 8. So we know that multiplication is commutative, so order does not matter. So what we want to do is gather these, number 6, gather these bases up in a way that makes sense. So I have an 8, an 8, an 8, and an 8. I have a -2, a -2, and a -2. So the -2 I have 3 of, and the 8 I have 4 of. So I'll write -2 to the third power, and everything is multiplication here, times 8 to the fourth power. So -2 to the third power is -8. And 8 to the fourth power is 4,096. And I did use a calculator. If I multiply those together, the answer I get is -32,768. So that one was a little bit tricky for us. We can do it. Remember, we can always do it. Stay with it and try, because our future is worth the work. Everything we're doing here is to make us better. So number 7, we've got fractions and we've got a 9. So the fraction is 2/3, and there are 2 of them. So that would be 2/3 that as a base raised to the second power times 9, and there are 2 of those raised to the second power. And 2/3 raised to the second power equals 0.444, and 9 to the second power equals 81. And if we multiply those together, we get 36. So now we're moving away from numbers and we're moving into letters, because we are getting you ready for algebra in 9th grade. So in number 8, we have a series of A's, and we need to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 A's. So our exponential expression will be A as a base, 9 as an exponent, and we read that A to the 9th power. However, we cannot evaluate that because we don't know what the value of A is. In number 9, we have the expression xy 1, 2, 3, 4, 5 times. So that would be xy, and we'll put that in parentheses, to the 5th power. And the reason we put it in parentheses is if we were to write it, I'll work over here, if we were to write it xy to the 5th, the exponent of 5 would only apply to the y, and that would not be correct. So we need to put that in parentheses. And again, we cannot find the value of those letters. So now we've got a mixture of R's, S's, and T's. So we've got R, 1, 2, looks like 2 R's. So that's our R to the second power times let's change the color to make it really clear. We have 1, 2, 3, 4, 5 S's. So times S to the 5th power. And we'll change our color again. For t, we have 1, 2, 3 t's. So that would be t to the third power. And again, we cannot evaluate those because we don't know what the value of them is. So let's move on to number 11. And we've got K's and 9's. Reminds us of a police dog. So we've got, let's count the K's. 1, 2, 3, 4, 5, 6. So we have K to the 6th power. And now we'll count the 9's. We have 1, 2, 3. So K to the 6th power times 9 to the 3rd power. And we cannot find the value of K. We don't know what K is supposed to be. However, we can evaluate 9 to the 3rd, and 9 times 9 is 81, and 81 times 9 is 729. And then we simply add that K to the 6th, and that's how we write that. So for number 12, we have -7 2 times. We'll keep the parentheses with the negative number, -7 to the 2nd power. And we have m and n. So we have 1, 2, 3 m's. So that's m to the 3rd. And we have 1, 2 n's. So that's times n to the 2nd. Now the m's and the n's we cannot evaluate. They will stay as is, but -7 times -7 is a positive 49, and we have our m to the 3rd, n to the 2nd. And then for number 13, we have this quantity of p minus 2, 1, 2, 3 times. When we have an expression in parentheses with a variable like that, we cannot evaluate the -2 separately. We are going to have to keep that p minus 2 in parentheses, and we just give it an exponent of 3. And again, we cannot evaluate that with that variable there. So that's a little trick to remember. I hope you took note of that. And finally, in number 14, we have a plus b times 6 times 6 times a plus b times 6. So how many 6's do we have? We have 3, so we have 6 to the 3rd, and we have 2 a plus b's. So that's a plus b to the 2nd power. Now, we can evaluate 6 times 6 is 36. 36 times 6 is 216. So that final answer would be 216 a plus b to the 2nd power. So let's go on to our second page. And I'm going to tell you a few things you need to know about exponents. So there's the zero exponent rule, okay? If you have a 0 as an exponent, okay, there's a special rule. So any number except 0, okay, except 0, when it is raised to the 0 power is defined as 1, okay? So it doesn't matter what the number is, provided the number is not 0, we define it as 1. So 1 to the 0 power equals 1. 2 to the 0 power equals 1. 3 to the 0 power equals 1. 4 to the 0 power equals 1. And x to the 0 power even equals 1 as long as x is not 0. We also have a negative exponent rule. And the negative exponent rule goes like this. If we have a base raised to a negative exponent, that equals that base in the denominator with that same exponent with a numerator of 1. And again, that is only if x is not equal to 0. So if we have 2 to the negative 2 power, we will write that as 1 over 2 to the second power, and we can further evaluate that as 1 over 2 times 2, okay, because in the exponent is repeated multiplication, which would make that 1 over 4. So let's practice all these rules that we've learned today and what we've learned about exponents. So we're going to write each expression using positive exponents, and we're going to evaluate if possible. We're going to find the value of. So 5 with a negative 2 exponent is 1 over 5 to the second, and we can evaluate that as 5 times 5, which would equal 1 over 25. So let's look at 8. Now, I'd like you to try some of these on your own before you follow me. So if you want to pause the video and try a few on your own, let's see how you do. I know you may need a calculator for some of them. Okay, so number 16. So that would be 1 over 8 with a positive exponent of 2, which is 1 over 8 times 8, which equals 1 over 64. And number 17, we'll rewrite that as 1 over 9 to the first power, and anything to the first power equals itself. So our final answer is 1 over 9. And number 18, we can rewrite that as 1 over 4 to the fourth power, which equals 1 over 4 times 4 times 4 times 4, which equals 1 over 256. So those were all great examples of how the negative exponent is evaluated. And let's go on to the next page. There we go. Number 19 through 24. And we're going to evaluate in number 19, we're going to evaluate 10 to the negative third. So let's change our color. So that would be 1 over 10 to the third, which would equal 1 over 10 times 10 times 10, which equals 1 over 1,000. 10 times 10 times 10 is 1,000. Number 20, I hope you try these on your own first. 2 to the negative 7th would be 1 over 2 to the 7th, which would equal 1 over 2 times 2 times 2 times 2 times 2 times 2 times 2, okay? That's 2 to the 7th. And 2 to the 7th equals 1 over, and 2 to the 7th is 128. These are final answers. Okay, now we're going to get some operations going here. So we're going to have 1 over 4 to the third times 1 over 7 to the first. And we're going to rewrite that. 1 over 4 to the third is 64 times 1 over 7 to the first is 7. And now it's just fraction multiplication. 1 over 64 times 7 is 448. So number 22, you're going to try it on your own. I hope you do. That would be 1 over 5 to the fourth times 1 over 3 to the second. So let's rewrite 5 to the fourth is 5 times 5 times 5 times 5. That's 625 times 1 over 3 times 3 times 3. I'm sorry, 3 to the second, 3 times 3 is 9, which would equal 1 over 625 times 9 is 5,625. And that's our final answer. So now we have 3 to the fourth times 9 to the negative 2 power. So 3 to the fourth. We can put that with a denominator of 1, by the way, just like any other number, times 1 over 9 to the second. Let's rewrite this. 3 to the fourth is 81 times 1 over 81. Do you see what's going to happen? We're going to have 81 over 81, which equals 1, because anything divided by itself equals 1. So now we're going to use the zero exponent rule, so that should be fun. So we have 8 to the negative third, which we will write as 1 over 8 to the third, times 10 to the second power, times 4 to the 0 power. Well, anything raised to the 0 power equals 1. So let's rewrite that. 1 over 8 to the third is 1 over 512. 8 times 8 times 8 is 512. 10 to the second is 10 times 10. That's 100 times 1. So that would equal, we can put ones underneath of these that helps us multiply. So that would be 100 in the numerator, 512 in the denominator. And both of those numbers are divisible by 4. So 100 divided by 4 equals 25. 512 divided by 4 equals 128. So our final answer, 25 over 128. Okay, great job. We're getting near the end. It's our last 4 problems. Remember, you are worth this effort. You're doing this for you. This is your future you're building, and I'm so proud of you for it. So x raised to the negative 9th power is 1 over x to the 9, and can't do anything else. We don't know what x equals. Similarly with a, so that would be 1 over a to the 4th, and we leave it there. That's our final answer. Now, r to the negative 6 times s to the 0 power times t to the 11th, that would be 1 over r to the 6 times s to the 0 is 1 times t to the 11th power. Okay, so all of these are numerators. These are all numerators because we could put a denominator of 1 under anything. So what we have is 1 times t to the 11th in the numerator, and r to the 6 times 1, which is r to the 6. That's our denominator. Were you able to figure that out? Let's see if you can do this last one. We have 3 to the negative third, which we will write as 1 over 3 to the third, times m to the negative fourth, that's 1 over m to the fourth, times n to the fifth, and we can always put a denominator of 1. So let's do this by multiplying across the numerators and then across the denominators. So in the numerators, we have 1 times n to the fifth. In the denominators, we have 3 to the third, which is not 3 times 3 times 3, 27, And then we have times m to the fourth times 1, and that is our final answer. So that is our lesson for today, except I did tell you that we have a special exit ticket today, and I hope you do it because it's a sliding puzzle and it has a special message about exponents in there. I know you love those sliding puzzles where you move the squares around until you get the puzzle picture to come into focus. So I hope you enjoy that sliding puzzle, and I hope you did well on our lesson. I know you did. I'm so proud of how hard you're working. Please remember to clear your area. Don't forget all your stuff when you leave. And go forth and take on the day. Have a great one. And remember, students, with practice, you'll be great.